Hi everybody. Today I get to talk to you about the Triangle Sum Theorem. We're going to do a little bit of a proof of it, show you why that it is true that the angles of a triangle add up to 180 degrees. Here's a quick look at that. I'm going to make a short look at that proof. And we're given triangle ABC, just given this triangle. And the first step, and most every proof we'll ever do, will always be given. So it's reasonable to write that term right there. This triangle is given. And then it tells me, through point C, show CD parallel to AB. I might show that segment AB. And that's an easy thing to do. I'm going to show a line through point C so that it's parallel to, I'm going to call that line CD. Through C, I'm going to show line CD so that it is parallel to AB. Might even put little arrowheads on those so you'll know that they're parallel. And you might be saying, hey, mister, what makes you think you can go around through a point, not a line, showing a parallel? And I'll tell you, well, that's the parallel postulate. And I'm going to abbreviate that this way. Parallel postulate. And you'll remember a postulate is something that we accept without proof. Postulate. And we accept that we can show through C, we can show a line parallel to AB. And if you're looking into my proof, you might say, well, we're going to talk about some angles now, aren't we? I think we could do this better if I call this angle 1, and that one angle 2, and this one angle 3. You ought to do that on your sketch also. So we can talk about them. And we're looking for alternate interior angles. And when lines are parallel, and we know that these lines are parallel, then you have congruent alternate interior angles. Maybe you could recognize them before I point them out. I would tell you, angle A is congruent to another angle. Looking for an alternate interior angle, and it would be angle A matching with angle 1. I might mark it that way. The angle at A is congruent to the angle at 1. Those are alternate interior angles. Likewise, the angle at B is congruent to the angle at 3. That's another pair of alternate interior angles. So I'll report it here. Angle B is congruent with angle 3. All of those for this very reason right here, because when lines are parallel, alternate interior angles are congruent. And then it's got this talk about a linear group sums to 180, and you think, well, what could that possibly mean? We've talked a lot about a linear pair, but here we have a linear group of angles. They're not a pair, but there's 3 of them, and they must be supplementary. They're not supplementary, but they do add up to 180. It takes 2 angles to be supplementary, and 3 of them could add up to 180, but we wouldn't call them supplementary. But I would say that a linear group sums to 180. And I'm going to write that this way. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 adds up to 180 degrees. Because I think we can agree that 3 angles that make a straight line together would also sum to 180 degrees. And then I'm going to do a substitution. I've shortened a little step, but I think we can make this work anyway. I want to rewrite this statement. Could I put something in the place of the measure of angle A? Yeah, angle A is, in the place of the measure of angle 1, angle A is congruent to angle 1. So I'll say the measure of angle A plus, and the way we drew this picture, angle 2 was what we called angle C before, wasn't it? So allow me to call that the measure of angle C. And then angle 3, is angle 3 congruent to angle 3 is congruent to angle B. So let me put an angle B right there, the measure of angle B. All adds up to 180. And you might not love that proof, but we have established the Triangle Sum Theorem, the theorem that says the 3 angles of a triangle add up to 180 degrees. Now we're going to look at ways to use that to solve various questions. And what you'll see today are very, very typical questions. Things that you ought to get used to and get good at working with. Let's take a look here. Let my camera focus, and here it talks about the 3 angles of a triangle ABC, angle A and angle B and angle C. And what I hope you're thinking is, well, those 3 things, if they're the angles of the triangle, got to add up to 180. So let's write that kind of an equation. 10x, and the second angle, angle B, is 6x plus 8. 6x plus 8, plus the measure of angle C, 9x minus 3, and these things should sum to 180. And we just did establish the Triangle Sum Theorem, and now we're applying it. And we'll just do what you got to do when you solve these little equations. We'll collect like terms I got 10x and 6x and 9x, and hope you agree that makes 25x. Plus, and I have a positive 8 and a negative 3. That'd give me a positive 5. And this still sums to 180. But let's do the task that we have at hand. Subtract 5 from both sides, and we have 25x equals to 175. Divide both sides by 25, and I bet you're as convinced as I am that x would equal 7. Because 7 times 25 gives me 175. Yeah, you could certainly say over 25 here and over 25 there, and x would equal to 7. But we are not yet finished. We got to find the measure of each angle, and that'll be easy. We'll just do a quick substitution. The measure of angle A should be, if x is truly 7, and we believe it is, then 10 times 7 makes that have to be 70 degrees. Measure of angle B, if x is truly 7, and 6 times 7 is 42 plus 8, that would be 50 degrees. Well, what about the measure of angle C, mister? Well, let's take a look at that. C is 9x minus 3, and x is equal to 7, and 9 times 7 is 63 minus 3, so that'd have to be 60 degrees. And you might check those, be sure they add up to 180. I'm pretty sure that they do. I can see that they would. Here comes another very typical question. The measures of the angles of a triangle are in a ratio of 1 to 5 to 6. Write the equation that fits and find the measure of each of those angles. And also we're going to look at exterior angles of this triangle. You'll see those things come up right away. First, when things are in the ratio of 1 to 5 to 6, you can call them 1x, 5x, and 6x. And for all the different values of x, these things would always be in a ratio of 1 to 5 to 6. But because they are the angles of a triangle, let's add them up to 180. These things are in the ratio of 1 to 5 to 6, and they are the angles of a triangle, so I know that they would sum to 180. And then watch what we can do with this. We get 6x and 6 more x, that's 12x. Adds up to 180. Divide both sides by 12. Does 12 go into 180? Yes, it does, nicely. And x would in fact be equal to 15. Just because 180 divided by 12 is 15. But now stick around. The angles were in a ratio of 1 to 5 to 6. We called them 1x, 5x, and 6x. And one of the angles would have been 15 degrees. The other one would have been 5 times x, and 5 times 15 would have been 75 degrees. And the last angle would have been 6 times 15, therefore 90 degrees. You could check on those. They do add up to 180 degrees. But now let's look at this idea about an exterior angle of a triangle. Let me lay these measures in this triangle. This angle was 15, and I'm going to say that this was the 75 degree angle. And over here I'm going to call that the 90 degree angle. And let me put a ruler on this and extend aside and get a look at some exterior angles. If you just extend aside, like I just did there, this is an exterior angle. And you're probably thinking to yourself, well, that angle is the supplement of 15. I can subtract 15 from 180, I'll know that measure right there. And I agree, that would work. In fact, if you took 15 from 180, that would leave this to be 165. But something I want you to catch. These two angles add up to 165. There is a theorem that says an exterior angle of a triangle equals the sum of the remote interior angles. That this angle equals the sum of the faraway interior angles. And those add up to 165. So I'm convinced that this exterior angle would have been 165 also. And you notice that those add up to 180. Let's extend another side. This would give me another exterior angle. And it's pretty clear that that exterior angle should be 90 degrees. It's the supplement of 90. But I would ask you again, is it true that this angle equals those two angles added up? Yeah. An exterior angle of a triangle equals the sum of the remote interior angles. So we get another 90 degree angle right there, don't we? I'm going to extend another side and get another exterior angle. And we're going to find its measure. And I could have extended it that way, but you might be thinking, what if you extended the other side this way? Let's take a look at that. So maybe I have two different exterior angles at that vertex. But I'm going to say, look, man, they're going to be the same amount, aren't they? Aren't those angles going to be congruent? Because those are vertical angles. And I would tell you that this angle equals the sum of those two right there. And the sum of those two right there, that'd have to be 105, huh? And after the fact, you might say, well, those are going to add up to 180, and that's just what should happen. And this exterior angle is also the same as that one, also 105. So we know the measures of the interior angles. They were this amount, and the exterior angles come to as easily as well. Turns out the exterior angles always add up to 360, while the interiors always add up to 180. But the exterior angles were 165, 90, and 105 degrees. There we got the measures of the exterior angles. I want to show you some more very, very typical questions. Check this one, please. It tells me that DB is the bisector of angle D. So we know that this angle and that angle should be congruent. I mean, just mark that way for us. Angle A is 50. We put that to work. And angle C is 60. And we really have three triangles here. And you should look at the large triangle first. Triangle ACD. We see two of the angles, 50 and 60. Those add up to 110. So how much would be left for this full angle here? Since those add up to 110, you subtract that from 180, this full angle would have been 70. Angle ADC was 70. I did a bad thing here. I should have put a 1 and a 2 in these positions. Let that be angle 1 and that one be angle 2. That's what I meant to have happen here. And you're remembering that since DB is an angle bisector, then these two angles would be congruent, and they add up to 70, huh? So they must be 35 apiece. 35 there and 35 there for angles 1 and 2, where it had been bisected. So we've worked on the big triangle, but now we can work on the smaller triangles. Let's find this angle. I think I'd ask about that one, angle ABD. Yep. There's a couple ways we could think about this one. I'm going to remember that that angle right there was 35 degrees. And this one was also 35 degrees. This angle, you could add up these two angles, certainly you could. 35 and 50 add up to 85. Subtract that from 180, you would know this measure. But it will be the same as these two angles added up. This is an exterior angle on this triangle. It'll equal those two angles added up. That angle would be 95 degrees. So I should report over here that angle ABD is 95 degrees. Now that kind of tells me about this angle, doesn't it? Those got to be supplementary. They make a linear pair. But I would tell you that this angle is equal to those two angles added up. An exterior angle on a triangle equals the sum of the remote interiors. Those two add up to 85. So this angle right there had to be 85 degrees as well. And that was angle CBD, 85 degrees. Now, we got another page to look at with very similar kinds of questions. Let's jump in. You get ahead of me, and I'm going to show you how I think they work. And we'll walk through this page together. You'll take it a triangle time as we use the Triangle Sum Theorem. Use the Triangle Sum Theorem and find a measure of each numbered angle. This one's pretty friendly. Looking at this triangle ABC first, and I see two of these angles are given, and they sum to 100. I know the angles of the full triangle got to sum to 180, so I think I know about angle 1. It must be 80. That way they add up to 180, huh? And I hope you're thinking what I'm thinking, that angle 2 is as big as angle 1, because those are vertical angles. That's another 80 degrees right there. I should put it here. Now, it talks about angle 3. And now angle 3 is an exterior, no, angle 3 is adjacent to this exterior angle, but angle 3 is the linear pair with that 140 degree angle. So what do you think about angle 3? How big should that have been? I'd report it to be 40 degrees, since that would add up to 180 together. So angle 3's got to be 40. So what about this angle 4? Now here's what I think is a cute idea. This 140 should equal these two angles added up. So 140, take out that 80, would leave me with 60. I'm thinking this would be 60. But you might look at it differently. You could add up these two angles, and they would add up to 120. I'm just thinking of the three angles in this triangle. These two angles add up to 120. Subtract that from 180, and you'd get 60 for this angle at 4, wouldn't you? So I'm thinking we're safe with those. And here comes that very typical question. We're given the three angles of a triangle. Write an equation and find the value of x, and please find the measure of each angle in the triangle. I think it's good to use parentheses here just so we keep these ideas separated. These expressions, I meant to say, these expressions separated. 6x plus 12 plus 5x plus 5x plus 40. Yeah, these are the angles of a triangle. They're going to add up to 180 degrees. So let's sort through there, clean this up, and collect like terms. I see 10x and 6 more. There's 16x. I have this positive 12 and this 40. That's going to give me 52 equals 180. I think we ought to subtract 52 from both sides, huh? To get this, isolate this 16x. And that will tell me about 16x if 180 minus 52 is 128, I think. Yeah, that's correct. I think so. 16x is equal to 128. And we'll divide both sides by 16. And I'm pretty sure that 16 goes into 128 8 times. I know that, yeah, I just know that x would equal to 8. You do that division yourself. See how many times 16 goes into 128, and I'm pretty sure it's 8. 8 times 16 is going to give me 128. I'm not yet finished with this question, though. Let's find the measures of all the angles A, B, and C. The measure of angle A, since it was 6x plus 12 and x is equal to 8, 6 times 8 is 48, plus 12 would make that angle be 60 degrees. Measure of angle B ought to be 5x, and 5 times 8 is just going to give me 40. What about the measure of angle C? I already have an opinion about it since these add up to 100. Let's see. If the measure of angle C is 5x plus 40, but x is equal to 8, and 5 times 8 is 40 plus 40. Yeah, that gives me 80. And you might be already thinking, well, the angles of this triangle add up to 180, and that's a pretty good thing that they do. That's got to happen every time, huh? But let's look at this next figure, please. Triangle PQR has angles with measures in the ratio of 1 to 2 to 3. Write an equation that uses that ratio and find the measure of the angles in the triangle. Also find the measures of the exterior angles of that triangle. An important idea. When things are in the ratio of 1 to 2 to 3, you can call them 1x, 2x, and 3x. For any situation, these things for any value of x will always be in the ratio of 1 to 2 to 3. But we'll recognize in this situation, these represent the angles of a triangle. So we know they're going to add up to 180. And then you gather like terms and you see, well, we have 6x equals 180. We want to know the value of x. We'll eliminate this multiplication with 6, divide both sides by 6, and you get x equal to 30. Not finished with this question, but the angles were 1x, 2x, and 3x, and if x is equal to 30, then the angles would have been 30, and 2 times 30 would have been 60, and 3 times 30 would have been 90 degrees. Let me just put those into my sketch over here. What apparently they look like they would go. This looked like it probably is that 30-degree angle. This one looked like it might be that 60-degree angle. And I'll take this to be that 90-degree angle. So let's find out about these exterior angles of that triangle. Here I got the interiors. The interior angles of the triangle, and now I care about the exterior angles of the triangle. I would tell you that this exterior angle at P must equal these two numbers added up. They must add up to 150. You may not think that's very powerful right now, but I know later in the year that becomes very useful. We'll have a 150-degree exterior angle there. What about the exterior angle here at Q? Ought to equal these two added up, huh? Yep, it's going to have to be 120. The supplement of 60, also 120. And then the exterior angle at R, it's going to be 90, isn't it? But doesn't this angle also equal the sum of those two angles? Yeah, an exterior angle of a triangle does equal the sum of the remote inside the triangle, but far away inside the triangle angles. So the exterior angle at R was also 90. We get another chance to look at this question, and it's a pretty good question. Here's another angle bisector circumstance, and you got to keep that thought in mind. This question is going to come back to haunt you. CD bisects angle ACB. Right off the bat, we ought to mark that these two angles are congruent. And it tells me that angle DCB, this angle, is 32 degrees. And angle CDB, let me get that right, CDB, this angle should be 98 degrees. And using those thoughts, I'm supposed to find out every other angle in the triangle, all the numbered angles. I'll take it a triangle at a time. That's all anybody could do. Let's focus on this right triangle at the first. I say right triangle. The triangle on the right-hand side. It's not a right triangle, though, is it? But this triangle that I'm bordering now, I see two of the angles, this 32 and this 98. That adds up to 130. So what about this guy? I know that they have to add up to 180. I take that 130 out of that 180. I know that that angle right there has got to be 50. Angle 1 had to be 50 degrees. Now, what about angle 2? That's this one. Yeah, that's right. This was an angle bisector, wasn't it? So it's divided into two equal parts, equal in measure. So angle 2 had to also be 32 degrees. Now I'm curious about angle 3. I would tell you, angle 3 is an exterior angle on this blue triangle right there. Angle 3 ought to equal those two angles added up. And those two angles add up to 82 degrees. So I'm convinced that angle 3 would be 82 degrees. And you guys who say, well, these better add up to 180. Yeah, I agree, they should. If that one were 82 and that was 98, they do add up to 180, so I'm happy about that. Hey, what about angle 4? To get angle 4, I have to focus on just this single triangle, triangle ADC. I do know two of the angles. This one was 32, because it was an angle bisector. Those were the same. And this one's 82. Let's see, 32 and 82, that's 114, I think. And if I subtract that 114 from 180, 180 minus 114, I'm thinking that I'm going to get 66 degrees for that one. But I might want to check myself on that. I know that these two angles should add up to this amount right there. And 66 plus 32, yep, that adds up to 98. So I'm thinking that 66 had to be correct. Now I've got a couple things for you to work on. Hope you'll give them a good shot.